Yes, hello guys. I am back again for the second video, still on Google IT Support Professional Certificate on Coursera. As you can see, this is my account on Coursera, my name. Again, I want to quickly give a shout out to Step as a company, as an IT firm. I won this scholarship to participate in this Google IT Support Professional Certificate through Step Scholarship Program. That's the access giving me this Coursera Google IT Support. Of course, I have Coursera account initially, which is a paid account on Coursera that I've been using to do courses on Coursera, but right now I'm on Step Scholarship Program. So the gist of today is the bit and byte of computer networking, week 2, and the assignment is routing paths and subnets. Routing paths and subnets. First of all, before we proceed, we should be able to understand the classes of IPv4 network address. We have about 5 classes of IPv4 network addresses. We have a class A IPv4 address. In order for you to be able to identify an IPv4 classes address, first of all, you check the first octet. IPv4 normally have 4 octets, so you check the first octet. Whenever you have an IPv4 address that has its decimal number starting from 0 to 127, that such of IPv4 address belongs to a class A IPv4 address. When you have an IPv4 that its first octet begins from 128 to 129, that is a class B IPv4 address. When you have IPv4 address that its first octet ranges between 192 and 233, that is a class C IPv4 address. When you have the one that its first octet ranges from 224 to 239, that is a class D IPv4 address. And of course, for the class E IPv4 address, when you have an IPv4 address that its first octet begins from 240 up to 255, that is a class E IPv4 address. So now, as you can see from my account, I've actually passed this graded assignment with 100%. So we're just going to do it again. Then right now, let's jump into scoring 100% in the routing part and subnet assignment. Let's go. Yes, first of all, we need to read the instruction. The instruction says, let's see how much you have learned about routing part and subnetting. In this activity, you are given a bunch of, take note, a bunch of source and destination IP address pairs. Now, let me quickly explain something here. In the networking, we have what is called network address space. Remember that your node, that is your system, your computer, which is called node, can be a source and can equally be a destination. Now, let's look at an example of you are trying to send an email to a friend of yours. So your own IP address becomes the source IP address, and your friend's computer, where the email will be sent to, becomes the destination IP address. That's his own connection, his own networking connection that he is connected to. His own IP address will be the destination IP address. So now, to clarify this, when you are connected to the internet, the IP that is assigned to your computer does not actually belong to your computer. It is being assigned by DHCP, which is called Dynamic Host Configuration Protocol. Dynamic Host Configuration Protocol assigned the IP address to your computer from the network space IP address, the network space. And it is the network space IP address that is usually being subnetted. It is the network space IP address that is usually being subnetted. So let's now go to answering the question. Now, before we start, as you can see, this is source, this is destination. Now, when you look at all this, you can see this is /24 /16 /26 /24 /16 /26. These are all network space addresses. These are all network space addresses, which means when you are sending a message from your own computer, from your home computer, you have a source address. It will have to pass through the network space address of your own system to the network space address of your friend before it will get to your friend IP address of his own system, which is destination. Now, to clarify this again, as you can see, this is 192, the source address, 192, 168, 1254. Destination is 10, 1, 1, 254. This 192 belongs to a class C IPv4 address. Remember, we said we should take note of the first octet for us to be able to classify the network. This is a class C IPv4 address. This is a class A IPv4 address. And remember, in IP addresses, we have what is called network ID and host ID. For a class A, the first octet, example of this for class A, the first octet is the network address or network ID, while the remaining three octets are the host ID. For a class B, the first two octets will be the network ID and the last two will be the host ID for class B. Now for class C that we have here, for instance, the first three octets will be the network ID, while the last octet will be the host ID. So in order for you to be able to answer this question correctly, you must first of all take note of the network ID of each and every corresponding source and destination ID with respect to the network space with respect to the network space IPv address. So look at this. This is class C. We have to look for the corresponding network ID in this network space address. That is how we know where to start from, because it is coming from here, source, and it's going to destination. Now let's take a look at it. 192.168.1.254. 192.168 is 0. This is not it. This is wrong because the network ID of class C is 3, and the 3 of the octet must correspond. Look at this. 192.168.1. This actually looks corresponding to this, but it is not still the correct answer simply because the last octet, which is the host ID of this, is 254, and this is 0. 254 is very far from 0. 0 and 254 are very far away. So it means that this cannot be your own network space. Let's take a look at this one. This is 10.1.1.254. This 10 actually corresponds to this network ID. For the host, we have 1. They actually correspond for the beginning of the host. And 1.254.0.1 is 1.0.0 can still go. But in this particular one, the correct answer here is source and destination not present, simply because of this 254 and this 0 is very far away. Now let's click. As you can see, immediately I click, it turned green already, which shows the answer is actually correct. If it doesn't turn green, it will be red, and that will alert me that the answer is not correct. So I'll click on check to move to the next question. Now, question number 2. 192.168.1.81. This is also a class C IPv4, and this is still a class A IPv4. So now let's check. 192.168.1.81. 192.168 is 0. It means the corresponding network address are not yet correct, are not yet complete in this one to this one. Let's check the second one. 192.168.1. 192.168.1. This is correspondent. Let's take a look at this one. 192.168.1 is 0. This is 0. But again, this will be wrong because 0 and 81 are still far apart compared to 64 and 81. This is 81. This is 64. They are close by. So which means you are starting from here. You have gotten that. Look at the destination. 10, 1, 254 254. 10 1 shows the very first host ID of 1 correspond to this 1. So these two are no. So for the part that you are coming to this destination, to this destination passing through the network space ID, it means that you have to come from here because this 64 and 81 are close by. So 1, 2, 3. Then you check. As you can see, they turned green. The parts that I clicked on turned green, so which shows the answer is correct. Let's move on to question number 3. You will understand more as we move on. For the third one, the source 192.168.1.1. It's also a class C IPv4 address going to destination of 192.168.165 from class C to class C. Now let's see. 192.168 is 0. This cannot be. I'm checking for the source. 192.168.1. 192.168.1, the corresponding network ID. Now 192.168.1 is 0. When you look at this 0, you will notice that the network space ID has its last octet one step backward or one step behind or one step down compared to this source last octet because 1 and 0 are not far away from each other, and 65 and 64 are not far away from each other, which means also this network space ID of destination of 64 is one step backward, one step behind, one step down compared to the destination IPv4 address, which is 65. So in order for you to get the correct part in this one is if you go like this, like this, like this, like this, you can see it's 4, which will be wrong. But what you are looking for is the shortest part so far. Shortest part so far is what you are looking for. So in order for you to get the shortest part, you have to go this way, this way, this way. This is 3 steps compared to 4 steps. So let's check our answer. As you can see, it turned green to show that the answer is correct. 3 of 8. Let's move to question number 4. For question number 4, for the source IPv4 address is class A. Destination is also class A. So what we'll be looking for is network space of class A to class A. For the source, we have 10, 1, 240, 240. We have 10, 1, the first host ID. They have actually corresponded 1 and 1. You hold that. Now For the destination, 10 2. 10 2. Network ID, the very first host ID, 2. They have also been in correspondence. So again, remember, shortest path. If you come this way, this way, this way, this way, it will be 4 paths. But we are actually looking for the shortest path. The shortest path here will be 1, 2, 3. Now let's check. As you can see, it's also turned green to show that the answer is correct. Let's move to the next question. Question number 5. 172, 1601. This belongs to a class B. Moving from source of class B to a destination of class A. So let's check the network space address that corresponds to this class B. Take a look at this. 172, 1601. Remember, for class B, the network ID will be the first 2 octets. 172, 16. Network ID, they correspond. The first host ID, which is the 3rd octet, 100, 100, they correspond. The last host ID, 1 is 0. Remember, as I've said earlier on, the network space ID, we have 1 step behind the source ID. So, which means for this, you are starting from here. Now, let's take a look at the destination. Network ID, 10, 10, 10. First host ID, 2, 2. They correspond. 1, 1, 1 for destination is 0 for the network space. 1 step behind, 1 step backward. So which means you are moving from here to here, just 2 steps. Let's check. You can also see it turned green, which means we are also correct. 5 out of 8. Let's move on. The next question, from class A to class A. Let's check the corresponding network space ID. 10, the first network ID, the first host ID rather, 3. There is none of this network space ID that correspond to this 10 3. There is none. But for this, we have, for destination, we have 10 1, 10 1. Though these almost correspond, but simply because of one of either the source ID or destination ID do not correspond, the best answer to choose in this case is source or destination not present, because this source is not present in this network space ID. Now let's click. You can see also it turned green immediately to show that our answer is correct. Let's move to the next question. Question number 7 out of 8. 192, 168 is 0, 128, class C. 192, 168, 1, 128. From class C to class C. Now let us check. 192, 168 is 0 as the network ID. 192, 168 is 0. Network ID correspond. For destination, 192, 168, 1. 192, 168, 1. Also what? Correspond. So now 128 as the last octet, which is still part of the host ID. This is 0. 0 and 128 are very far apart. Imagine counting from 0 to 128. They are very far apart. Also, look at this also. 128 is 0. Imagining counting from 0 to 128, they are still very far apart. So which means the correct answer in this case is source or destination not present. Now let us click. As you can also see, it turned green immediately. Shows what? We are correct. Let's move to the next question. 6 out of 7. Question number 8. We're moving from a class C IPv4 address to a class A IPv4 address. 192.168 is 0, network ID. 192.168 is 0, network ID. They correspond. Now, destination ID 10 to 101. 10 to the first octet, the second octet, which is the first host ID for this destination, they correspond. So for this, 192.168 is 0. 192.168 is 0. Then 73 and 0, they are not far apart. 0 and 73, in this case, they are not very much far apart compared to counting from 0 to 128 as previous. So this is the logic. They are kind of logic that I just need to just understand. Don't just understand those kind of logic. So which means for this assignment, I'm coming from here to here. And another thing that we should take note that I've said that the last octet is always like one step backward, one step behind. Look at this. 0, 1. So let us click. 1, 2, 3. Let's check. You can also see it turned green. Remember what I said, 73 and 0 are not very much far apart. So that is the correct part for this. As you can see, we never failed anyone. We got 8 out of 8 without trying for the second time. And we have congratulations, you have completed the activity. Please submit the quiz. Once again, I say thank you to Start Step Scholarship that gave me this opportunity to be able to participate in this course. And at the same time, I'm using that opportunity to teach you guys, my fellow colleague, on the Start Step Scholarship, because you guys have been asking me a lot to help you out one way or the other. That's why I'm making this video. And at the same time, being kind of person that I enjoy teaching also, it's equally part of me to make sure I showcase this to equally teach the whole world about network, about routing paths and subnetting. If you enjoyed this video is very useful to you, please like and subscribe. So let's submit. Hi, my name, then I am submitting. 100% again. Congratulations, you passed. Always 100%. Once again, thank you for liking this video. Please share if you like the video and give a thumb up.